Up to this point, we have only covered using if statements with conditions that have Boolean values of true or false. JavaScript allows other types of values to be used as conditions by treating them as if they were true or false. Let's look at an example before discussing how this works. This code outputs the name is not empty, which is correct, but the name variable holds a string and not a Boolean value. If we change the value of name to an empty string, the code correctly outputs the name is empty. It is able to do this because the string John is treated as if it was a true value, and the empty string is treated as if it was a false value. There's nothing special about the name John, but there is something special about empty strings. The ability of a non-Boolean value to be treated as Boolean is the consequence of something known as type coercion. When a specific type is required but a different type is provided, the value that is provided is coerced to the type that is required. Let's look at an example of type coercion with a number and a string. You might expect this to output the number 10, but it actually outputs the string 55. Recall that the plus sign can be used both for adding numbers and for concatenating strings. A string cannot be added to a number, but a string can be concatenated with another string, so the number 5 is coerced to a string. This produces the same output as if the first 5 was also a string. Observe what happens if we change the plus to a minus. Subtraction is a valid operation for numbers, but it is not a valid operation for strings. So the string is coerced to a number. The result is the same as if the second 5 was a number. If we use strings for both 5s, it still results in 0 because both 5s get coerced to numbers. Note that it's not showing 0 to indicate an error or to indicate that the operation could not be performed. We can change that to different numbers in string form and get a proper answer that isn't 0. This outputs the number 6 because both the 8 and the 2 are coerced to numbers. If the value on either side of the minus sign cannot be coerced to a number, then it becomes NaN, which is an acronym for not a number. Any math performed on NaN will also produce NaN as the result. When we apply this concept of type coercion to Booleans, we can produce true or false values by coercing other types to Booleans. A value that is treated as false is referred to as falsy, and a value that is treated as true is referred to as truthy. The only falsy string is the empty string. All other strings are truthy. Note that the word false in string form is truthy because it is not an empty string. Since the string John is not an empty string, it is a truthy value. This allows us to use name by itself as the entire condition of the if statement. The more verbose form would compare the name variable to the empty string. This code behaves in the same way as the previous more concise version. The numbers 0 and -0 are falsy. In regular math, there is no -0, but it exists in computer science due to how numbers are encoded. We won't be going into details about that here. Just remember that all forms of 0 are falsy. Note that there is also a special form of the number 0 written as 0n, and this is also falsy. We will discuss this special type of number in a later video. NaN is the only other falsy number. Confusingly, this is actually classified as a number despite explicitly declaring itself to not be a number. All other numbers are truthy, and that includes all negative numbers besides -0. This is an important point to remember, especially in regard to -1, because that specific number is sometimes used to indicate that something hasn't been found. But -1 is not a falsy value. We have not yet encountered any situation in which -1 has a special meaning, but we will later in this series. Back when I introduced the topic of variables, I mentioned that a variable that hasn't been given a value will automatically get the value of undefined. This is also a falsy value. Note that being undefined is fundamentally different from being an undeclared variable. If I comment out the let statement, it produces an error instead of treating the variable as falsy. Undefined is considered to be both a specific value and its own type, which has no other values, so there is no truthy variant of this type. The only other falsy value that you need to know about is null. This is a special value which also indicates the absence of a value. It is similar to undefined, and it also has its own type with no other values besides null. The main difference between null and undefined is that null has to be assigned explicitly, while undefined is automatically assigned if no other value is given. It also distinguishes itself from undefined by indicating that there wasn't a failure on the part of the programmer to assign a value. There is one final falsy value, but you don't really need to memorize it. It's a deprecated property of the document object called all. We will discuss what the document object is in a future video, but we will not discuss document.all because it's deprecated. I mention it now only for completeness, but it's something you should never use, and you are not likely to see it in any code. There are only a few falsy values, and we just covered all of them, but there are a tremendous number of truthy values. All values that aren't falsy are truthy, so it's easier to just remember the falsy values. Any value that isn't one of the falsy ones must be truthy. The most common way to use truthy and falsy values in if statements is to test if any value is present. Notice how 0, null, undefined, and an empty string all indicate an absence of value. NaN doesn't indicate nothingness, but it does indicate that a value is invalid, so it too can be treated as if no value was present in many circumstances. This code correctly rejects the name if it isn't a proper non-empty string. The name value might have never been assigned anywhere in the code. In that case, it would be undefined, which is falsy. It might have been given an initial value of the empty string or null, but no subsequent value was obtained, so it would also be falsy. The name variable only becomes truthy when an actual name is assigned to it. Note that the concept of truthy and falsy can be used in other situations besides if statements, but we won't be covering that right away. Next time, we will continue with the topic of the if statement for the third and final part of the series on this topic.